Hi guys, today I'm going to take a look at many of the different ways that you can run containers on Azure. There's a lot of overlap between some of these. Some of them are fairly niche depending on which one you're using. So I want to try to give you a lay of the land to try to figure out which one of these might be the best for your application or workload. So we're going to be looking at these at a very high level and try to give you some of the use cases and the purposes behind some of these offerings so that you can be at least somewhat informed about what you're going to be using these for. I'm not going to be able to get into any of these in depth. Simply the length of this video doesn't allow for it, but I will be doing deeper dives into these in future videos. But in any case, let's just dive right in and start looking at some of the available options on Azure. So we're going to look at this list with the name of the option, its purpose, and its scale. So the first one on the list is Azure Container Instances. Now this is a great option for ease of use, as well as creating workloads that are more ephemeral in nature. That is, you start it, you run it for a while, then you shut it down. Now, this one has a serverless billing model, so you basically just pay for the time that you use and nothing more. You're not reserving capacity. It's going to take some capacity from the available pool. It's going to run your container for a period of time, and then it's going to shut down, and you're only going to pay for the number of seconds that your container is actually running, and no more and no less. So this makes this great for those more transient style workloads, but if you need something that's going to run 24/7, choose one of the other workloads on this, because it could be very expensive to run a 24/7 workload on ACI, but very cheap to use it for those transient style workloads. So the second one on this list is Azure Functions. Now, people don't typically think about functions when they think about containers, but it can run containers in the same way that it runs functions on Azure. Now, Azure Functions is an event-driven programming paradigm. So what that means is you respond to some kind of event in the environment. It could be a web request coming in and you're responding to that web request, you process it, and then you return a response. It could be something like a message queue where you're reading a message from a queue and processing that message and then doing something with the output. Or it could be something like writing data to a database, like with Cosmos DB, where new data coming into the database is written to a table, and then the change feed can trigger an Azure function to do something with that data. All of these are events, and Azure Functions respond to events in the environment. Now, you typically use one of the available programming environments for this. You could use Node.js, .NET, you could use Python, or one of the other supported languages. But if you don't have a language that is supported natively by Azure Functions, you can write your function in a scripting language or some other means and put it into a container. And then Azure Functions will use that container the same way it uses one of these more native languages that it does support out of the box. So this allows you to bring your own code to functions and then just have functions orchestrate that container. Now, the container will be started and then stopped in the same way that functions are started and stopped. So you have to take that into consideration. If it has a long boot process, that could be a problem. But if it doesn't, it could be a great way to use some kind of a third-party code inside of Azure Functions. So the first two on this list are more of a serverless offering. The third one is Web Apps for Containers, which runs on top of Azure App Services. Now, this is going to be more conducive for traditional style applications that are more monolithic in their approach. So traditionally, the way that apps were built for the web is you would take a scripting language or some kind of compiled code, you'd write an application, then deploy it to a web server. The web server would then receive requests and then forward those requests onto a runtime environment that would execute that request and then return a response. So it was a fairly monolithic stack that was used to write these applications with. And App Services typically follows that same paradigm, and it's useful for that style of application. So this is going to be able to run PHP applications, ASP.NET applications, Node.js applications. You can run Python code. There's a lot of other languages that it supports natively out of the box. Now, if you want to write your application in some other language, such as Ruby, you can bring that containerized Ruby code to App Services, and it'll run just like one of the native platforms will, except you are running it in your preferred language rather than one of the native ones that comes out of the box with App Services. So this allows you to bring your own code to Azure with containers. Now, the next one on the list is getting into a more highly scalable solution, and that is Azure Container Apps. Now, I like to think of this one as a managed Kubernetes experience. In other words, it's going to be Kubernetes under the covers. And if you poke around at this, you'll be able to see some of the Kubernetes underpinnings of Azure Container Apps, but it doesn't doesn't expose it quite like some of the other offerings do. Instead, with this one, you end up having a more managed experience where you can deploy containerized workloads to this environment, and it's going to provide all of the infrastructure and all the abstractions you need so that you never really have to manage any of the clustering technology. You simply tell it how you want to scale your application and what your application is supposed to use, and then it kind of does the rest for you. It's much more opinionated than obviously a Kubernetes environment would be, but it does give you the ability to have a fully managed experience for highly scalable applications. And this one is squarely designed for microservices, but it can also run general web apps as well, as long as they're running inside of a container. So the next one on the list is the flagship offering from Azure, and it's Azure Kubernetes Services. So this is a partially managed offering on Azure that runs a Kubernetes cluster. I like to think of it as managed infrastructure, but it's a shared responsibility for the management of the cluster. So Azure is going to provide a lot of the orchestration and integrations with the Azure resources that it uses, but you still have to be aware of what it's doing. So it's going to be creating VMs. It might create things like IP addresses and load balancers and application gateways that are all going to work together, and it's going to orchestrate those through the control plane for Kubernetes. But you don't have to worry about all of that complexity. And you don't have to worry a whole lot about deploying the VMs themselves, because Azure is going to take care of that. And you don't have to worry about patching in the Kubernetes cluster. But if you do customize those images that are going to be deployed with Kubernetes services, you need to be aware of what you're doing with this particular offering on Azure. So there's a shared responsibility between you as a user and Microsoft as a service provider for running Kubernetes in this context. Now, once you spin up Azure Kubernetes services on Azure, you have available to you pretty much a standardized form of Kubernetes. So you can run pretty much anything on this environment that you could run on any other Kubernetes environment like EKS on Amazon or Kubernetes on-prem, wherever you might be running it. Still, it's more managed than a fully manual install of Kubernetes in any case, and this is probably one of the most popular options on Azure because of that. So the sixth option on this list is Service Fabric. Now, Service Fabric is a homegrown orchestration layer that Microsoft wrote in-house, and it drives a lot of what we see on Azure, whether you realize it or not. They generalized it and made it available to the public for general consumption. Now, it has its own programming paradigms that you can adopt, and typically people that are using Service Fabric adopt these programming paradigms that come with Service Fabric. However, it can use containers. Now, would I use this as a container-only platform? I wouldn't, but if I'm running a Service Fabric application and I also want to run containers alongside of that, it's a great option to kind of marry containers with Service Fabric applications in the same cluster that you might be running otherwise. So it's a really neat offering if you already are using Service Fabric, but otherwise I don't think I would use it for containers unless I was already using Service Fabric for something else. So the seventh option on this list is Spring Apps. Now, Spring Apps are anything that uses the Spring framework. So this could be a Spring Boot app or a Spring app if it's using a more modern iteration of it. And these are designed to run microservices and web apps typically written in Java. Now, you don't have to write Spring apps in Java to take advantage of the Spring framework. You can write them in other languages, and there are language implementations for things like .NET and Node.js that can take advantage of the infrastructure that Spring apps offer without actually having to write any Java code. So the way you do this is containerizing that code and then bringing it to the Spring framework or to Spring apps on Azure. Now, you can run the Java Spring apps natively inside of Spring apps on Azure, but if you want to use one of these other platforms that implement the Spring framework, you can bring that by way of container, and then you can pretty much write it in any language you want as long as it conforms to the patterns and principles of Spring. Now, if you're not using Spring, this is not something you'd want to use, but if you're already heavily invested in it, this is a great managed service that will give you the Spring framework supporting infrastructure, such as session management and some of the infrastructure for orchestrating deployments and scaling and all that stuff without having to create any of that kind of infrastructure yourself. So it's a great offering if you're invested in Spring. Otherwise, it's really not going to be useful to you. So the last one on this list is Openshift. Now, Openshift is a partnership between Redhat and Microsoft. I like to think of this as Kubernetes plus DevOps, because what Kubernetes typically does is manages containers at scale, and it also orchestrates the deployment of containers as well as managing those containers while they're in production, and Also, it manages a lot of the infrastructure underlying the containers that you're running, but it doesn't have much in way of logging or monitoring or security or DevOps built into the platform. So if you want to add those things to the platform, you either have to build them yourself, go to third-party tooling, or you would have to figure out some external tool to do a lot of that work for you. Now, Openshift kind of takes all of that and combines it into a single platform, so you can do all your builds, all your container hosting and registries, as well as all the security monitoring and logging in a single platform, so you don't have to piecemeal it all together yourself. So it's a nice offering if you just want a one-stop shop for everything you need to run containers. Otherwise, you might just want to think about using something like AKS or one of these other offerings that are a more managed platform if you don't want to have to manage a Kubernetes cluster of any kind. So if you were to think about all of these options on a single pane, I would look at it like this. On one axis, I would put complexity. So complexity increases from the bottom to the top. And then on the bottom axis, I would put scale. And this is the number of instances that you're going to be running inside of your application. So you have complexity and scale kind of going together. And as you increase your scale, you typically also increase your complexity. So if you were to put all of these offerings that we looked at for running apps on a single view, it might look something like this, where you have a lot of different options to run, but you have increasing complexity with increase in scale. So the simplest option obviously is ACI, which is the container instances. And that's a one-off type container that doesn't offer a lot of configuration for running the container, but it's very simple at the same time. So it has very low complexity. Function apps are similar to that. They have a little bit more complexity because you have the opinionation of the function app runtime that's going to be running the container and orchestrating that container. And it's basically going to inherit the complexities of function apps, but it's nowhere nearly as complex as some of these other options that you have kind of to the right of this. Now, slightly more complex than function apps is an app service. Now, this one again is fairly simple. Basically, you're just maintaining a web app on a web app environment, and you don't really have to worry a whole lot about the infrastructure. It's going to do a lot of that for you, but there's a lot more options available on app services for tuning the scale. So you can scale up and scale down the number of instances of your application. There's other options embedded in this platform that give you the ability to tune the web app to make it run well. So app services is not incredibly complicated, but it's not exactly trivial like ACI or even function apps is. So moving to the right, you have container apps and Spring apps. So container apps, like I said, is a managed Kubernetes environment. It's slightly more complex than what you would give at app services, but it's not nearly as complex as a full-blown Kubernetes experience because it is more managed. And you also have Spring apps. It's very similar to container apps, but it's more opinionated towards the Spring framework. And then, of course, onto the far right over here, you have AKS, Openshift, and a Service Fabric cluster. And these are all pretty much a shared experience between you managing infrastructure and Microsoft managing infrastructure on your behalf. And there's that shared responsibility model. Now, each one of these have multiple knobs that you can tune for the scale that you want to run. So AKS, for instance, allows you to have node pools, and each one of those node pools can have multiple nodes running in it, and each one of those nodes can have a different size VM. They're all going to be the same size VM within a node pool, but it's going to give you more scaling options within your cluster. So you could have one node pool that's running large VMs and another one that's running rather small VMs, but you can scale each one of those independent of one another. You can also scale the pods according to their needs on those node pools as well. So you have a lot more options in terms of scalability, but that adds a lot more complexity to the entire environment. So Kubernetes is certainly going to be a lot more complex than ACI, but then you have all of this middle ground that you can use to kind of pick which one of these that you want to use, depending on how much complexity you're willing to deal with to get the scale of application that you want or the control over the application that you want. So this list is slightly different than the other one. This is going to look at some of the more niche options, but still going to look at platform purpose and scale. But this is going to cover some of the more edge cases for the different kinds of offerings available on Azure for containers. So on this list, there are three options that I want to look at. And the first one is Azure Arc. And this really isn't a container platform as much as it is the ability to extend a control plane into Kubernetes clusters, regardless of where they're running. So you could run these on Azure, you could run them on another cloud like AWS or GCP, or you could run these on the edge, or in a data center, or you could even run it on IoT devices, depending on where you're running your Kubernetes cluster. Now, regardless of where you're running it, what this does is it extends your ability to manage those clusters from Azure into those clusters by applying Azure policy, and it provides some basic security as well as container orchestration within the context of Kubernetes. So you can deploy Kubernetes manifests from Azure into these environments at scale with a single tool, rather than having to go through each one of these different platforms to deploy the same kind of thing that you would otherwise do manually without a tool like Azure Arc to manage all that for you. So it's just really more about the orchestration and management of containers and clusters at scale than it is a container runtime itself. From this, we can look at two data-driven options, and the first one of these is Databricks. Now, most people wouldn't think about Databricks being a container platform, but it does have the ability to run containers. Now, the way this works is the way that Databricks works. It's just an added service in the context of Databricks. So with Databricks, you have the ability to write various algorithms and scripts using one of the integrated languages like R or Python, or some kind of SQL-like language that will process data. So you have the data in, you process it, and then you write the data out. It can do batch processes as well as data streams, depending on how you're using Databricks. Now, if you want to run something in a language that's not natively supported by Databricks, you can put that into a container. Or if there's a tool you want to use that's not supported by Databricks, you can put that into a container. And then you can do all of your data processing within the context of the container. But Databricks will just orchestrate it the same way it orchestrates some of the native tooling in Databricks. So it just gives you the ability to bring your own code to Databricks and run it like it was a part of Databricks without having to know any of the built-in languages. So if you wanted to write something in like C, you could do that, run it on Databricks, and it would work just like some of the other components would. Now, the last option on this list is Azure Batch. Now, Azure Batch is designed for high-performance computing. Basically, what you can do with this service is process large amounts of data across a cluster of computers on Azure. So this gives you the ability to orchestrate VMs, run them for a while, then shut them down. So your costs are going to be in line with what you're actually trying to do. Now, this is designed for processing large data sets that you wouldn't otherwise process with something like, say, Data Factory or even Databricks. It's designed for scaling up possibly dozens of virtual machines, maybe hundreds of virtual machines, and having potentially thousands of cores at your disposal to process data and to process that data for a while. Then when you're done, you then shut all those VMs down. Now, sometimes your workload is such that you have a complicated set of software that you have to install for that process to happen. So if you need a complex install process, you don't want to use Azure Batch to orchestrate the installation of that, because it's going to have to orchestrate that installation across every single node, rather than do it at boot time when the VM comes up. With Azure Batch, what you can do is build those environments in containers, and you can install all the dependencies. You can have all of the software pre-installed in the container and just have Azure Batch pull the container to run the processes that you need to run. And then the container will then be able to run the software in the context of the container, process all of your data on that VM, and then Azure Batch will dispose of the VM and then dispose of the container once your process is finished. So the container story in this one is very similar to how you might use it with something like Spring Apps, where you're running third-party code in that container, or what you might be doing with app services. But it just gives you an easier way to orchestrate the installation of that code and to be able to tune the dependencies and all that without having to rely on Azure Batch running a script to do that every time a new VM is created. You simply just pull a container and you start it with everything already configured in that container. So these are three options that are more niche. So you might want to think about using containers in these contexts. If you have one of these contexts in your environment, you need to do something like extend a control plane, or you need to do some kind of data processing in a container. So hopefully this has given you an overview of all the options that are available on Azure. A lot of these are kind of overlapping options, and it can be hard to figure out which one is the best option for your application or workload. In any case, hopefully this is giving you at least a little bit of context. I'm going to be doing deeper dives into some of these topics. I definitely want to look at AKS, container apps. I want to look at web apps for containers and ACI. And if there's something that you want to see or a specific topic, drop a comment in the comment section down below, and I'll see what I can do to get to it. As always, subscribe to the channel, like this video, and share it with your friends. And thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @theonemule. And as always, thanks for watching.